Good morning, dear student. In previous lecture, we already discussed the hydration of cement. So in this lecture, we discussed the remaining points. That is different materials which is used. Okay, such as plasticizers, then retarders and accelerators. So let's discuss this important material used in the cementitious material or for preparation of the concrete material. So let's discuss these admixtures. All these materials are called as admixtures. So this admixture is defined as admixture is defined as admixture is defined as a material other than cement, a material other than cement, water and aggregates. So whatever the material which is added, okay, in the concrete formation is defined as uh, admixtures. That is material other than cement, then water and aggregates. Okay, let's discuss the next point. That is this admixtures. This admixture. These admixtures are used. So admixture is defined as a material other than cement, water and aggregates. Okay, these admixtures are used to modify the properties of to modify the properties of ordinary cement or ordinary concrete. It is not cement, ordinary concrete. So admixtures are used to modify the properties of ordinary concrete so as so as so as to make it more suitable for any situation. So these admixtures are used to modify the properties of ordinary concrete more suitable so as to make it more suitable for any situation. So if you consider the classification of these admixtures, depending on the material which is used, so they are classified into two types. That is, if you see the classification of this admixture, they are classified into two types. One is chemical admixtures, one is called chemical admixtures, and second is called mineral admixtures. So the mineral admixtures we already discussed in the blended cements. So whatever the blending material or pozzolanic material which is added in cement, they are considered as a mineral admixtures, such as fly ash, then silica fumes, rice husk. So these are the examples of these mineral admixtures. And if you consider uh, the chemical admixtures according to the characteristic effect produced by them. So according to characteristic according to characteristic effect produced by them produced by them they are they are as follows. They are as follows. The first one, that is your plasticizers. Plasticizers. Also, the super plasticizer is also there. Then the retarders. Then the retarders. And the third one, that is accelerator or accelerating admixtures. So plasticizer, a retarder, and accelerator. Okay, so let's discuss the first chemical admixture, that is plasticizers. Okay, so we're discussing the first one, that is plasticizers. So if you consider these plasticizers, they are called water reducing. So decreasing the amount of water, they are water reducing. So what is the functions of these plasticizers? So if you see the one by one, that is the first one, to achieve the to achieve higher strength by decreasing water cement ratio by decreasing water cement ratio. So its function is to achieve the higher strength by decreasing the water cement ratio. Second, to achieve some workability by decreasing the cement content. To achieve some workability by decreasing cement content by decreasing cement content by decreasing cement content so as to reduce so as to reduce the heat of hydration reduce heat of hydration. So we already discussed that the hydration process is your exothermic process. Lot of heat is generated to reduce the heat of hydration in mass concrete. So the first function is to achieve the higher strength by decreasing water cement ratio. Second, to achieve the workability by decreasing the cement content so as to reduce the heat of hydration in mass concrete. If you consider the commonly used the water reduction, if you consider the water reduction with the help of this plasticizer, water reductions more than 5% but less than 12%. So this much water is get reduced, okay, with the help of these plasticizers. Again, if you consider the examples of these plasticizers which is used, okay, the plasticizers, the commonly used plasticizer, for example, if you consider, they are the commonly used admixtures. Okay, so the plasticizer is nothing but your admixtures. So they are lignosulfonates lignosulfonates so they are the admixtures, lignosulfonates. And second, that is hydrocarbolic acid salt. Hydrocarbolic acid salt. So these are the two examples of these plasticizers. Okay, they are the lignosulfonates and hydrocarbolic acid salts. If you consider these plasticizers are usually based on the lignosulfonate, which is a natural polymer derived from the wood. So, whatever the plasticizer, they are usually based on the lignosulfonate material, based on the lignosulfate, which is act as a natural polymers derived from the wood. Okay, this lignosulfonate absorb get absorb on the surface of cement or get adsorbed on the surface of cement particles and forms their thin sheath, and this thin sheath inhibits the surface hydration reaction between water and cement. So this is your lignosulfonate. It is your if you consider, it is your polymeric material. Polymeric material, it will adsorb. Okay, so get absorb, I think it is adsorb, get adsorb on the surface, of cement, get adsorb on the surface of cement and forms a thin layer, thin sheath, and the thin sheath inhibits the surface hydration reaction between water and cement. So this thin sheath, it inhibits the surface hydration surface hydration reaction of water and cement. Water and cement. So this is the first chemical admixture, that is plasticizers. So you should keep in mind their role. Again, there is one more, that is super plasticizers. The role of super plasticizers and plasticizers are same, but if you consider as compared to the plasticizer, super plasticizer reduces the water content significantly. Again, uh, reduces the cement content more as compared to these plasticizers. Okay, increases the workability, increases the long term strain, and if you consider, it is more useful as compared to these plasticizers. Both are useful, but among these super plasticizers are having more effective as compared to this plasticizer. So let's discuss the second one, that is retarders. Okay, the second admixtures, that is your retarders. Retarders. Okay, so the retarding admixtures, if you consider their function, so admixtures retarder admixtures delay the hydration of cement, delay the rate of hydration of cement. So retarders admixtures delay the rate of hydration of cement. Okay, in other words, we can say that it extend the setting time. It extend the setting time of of cement paste in concrete. So what is the function of this retarder as admixtures? So they delay the hydration of cement and increases the extent of setting time of cement paste concrete. Again, if you consider, they are very useful or helpful for concrete. that has been transported to long distance. So it is very useful or helpful. They are helpful for concrete, helpful for concrete that has been transferred, that has been to be transported, that has been to be transported to long distance, to long distance, to long distance, and help in placing the concrete at high temperature. If you consider the examples of these retarders, the examples are your calcium chloride. It is not calcium chloride, it is calcium sulfate. It is your calcium sulfate, and second one is your gypsum, and second one is your gypsums. So these two materials are act as retarders in the concrete. Okay, so they delay the process, that is the rate of hydration of cement, or extend the setting time of cement based concrete. The example is calcium sulfate and gypsum. Let us discuss the third one, that is your accelerators, accelerator admixtures. So accelerators, accelerator admixtures. If you consider these accelerating admixtures are added to concrete, so they are added to concrete, they are added to concrete, they are added to concrete to shorten or to decrease the setting time, to short the setting time, to short the setting time, and increase the rate of hardening, and increase the rate of hardening, increases the rate of hardening and strength development of concrete, and strength development, and strength development of concrete. So they are added to concrete to decreases the setting time and increases the rate of hardening and strength development of concrete. Again, if you consider their function, it increases the rate of hydration. Okay, so it increases the rate of hydration, it increases the rate of hydration. Again, they are used in cold weather condition. The second important is that they are used in cold weather condition, they are used in cold weather condition, they are used in cold weather condition. Again, if you consider the examples of these accelerators, so they are, if you consider the examples, they are your calcium chloride, CaCl2, then other chloride is also there, other chlorides, and then the silicates is also there, silicates. Okay, and then fluoride is also there, fluoride, then alkali hydroxide is also there. So they are act as accelerators, calcium chloride, silicates, fluoride, alkali hydroxide, nitrites and nitrates and nitrates and nitrates. Okay, and triethanol amine. The last one is your triethanol amine. Triethanol amine. So these are all act as an accelerator. Okay. Uh, so if you consider these accelerators, they are the admixtures that decreases the sitting time of the concrete and increases the rate of hardening and strain development of concrete. It increases the rate of hydrations and it is very useful in cold weather conditions, and you should keep in mind the examples. So this is all about the plasticizers, retarders and accelerators. Whatever the applications of this cement, so you have to find out the application of these cementitious materials. Are you are all familiar with the cement and concrete material, so you should find out the application of this cementitious material and whatever the remaining points of this cementitious material. In next lecture we will try to discuss some important points regarding to this ceramic materials. Okay, so we are not goes into very much details. At least you understand what is composite material, their classification, cementitious material, then the composition of the what is the composition of Portland cement, concrete is there, different material which is used and their role. Okay, so in the next lecture we try to uh, take a we try to understand the ceramic material. Okay, and one is biomaterials. So we'll discuss this in the next lecture. Thank you.